So great to be here at CES, and as always, working with our partners here at the show is the way we want to show up. Alembic has been on a great journey, I think, the last few years, right? Going from like 14 million, a relatively modest Series A, to 145 was it last year?
No, it was not even. I guess last year, and it's January, but 3 months ago, I think.
Yeah. So, I think all of that, without, being a frontier model builder, which is what, we see in the news a huge amount right now around big funding rounds, is incredibly impressive and is indicative of the depth that people are recognizing you guys are working at. But I'd be great for us to have a chat about, what you've seen change in that time from coming out and planning what you wanted to do in that time of the Series A to where you got to with the Series B round and the adoption and the traction that you've seen in the market.
Yeah, I think it is interesting because I think people are starting to come around to much more recently that AI is a much larger category than what people were first introduced to it in, say, 2022 is really when ChatGPT started really taking off, the end, right? Then to the early part of 2023. I think most people thought of, this very chatting style system. And I think people are starting to wake up that there's a much bigger world out there. And we took a position very early that, the data and the way it thinks about it, because, we're talking to a group of marketers here. We started on the marketing side of the house. And we recognized that most people would go, oh, we literally had phone calls where people were like, oh, marketers don't have that much data. Why do we even, why do we even care, right? That seems like a weird thing to put all those resources towards. And I'm like, I don't think you understand. Some of the marketing groups we work with, especially in Fortune 10, have more data than some countries.
Yeah.
Right. And so, taking this large understanding of data and ethos down into the market, I think it let us be able to actually bring results that were not possible before.
Yeah.
And I think that it's how do you measure what everybody considered unmeasurable? Just like how you build it.
It's interesting as well because it's not like, the conversation around data definitely isn't new. That's almost like it was one of the biggest technology cycles prior to modern AI blowing up around the GPT stuff. But people were still trying to figure out how do you get to the gold in that data? Yep. The answers are there. But the maths and the technology and the application of neural networks and the advanced sort of work that you guys are doing wasn't being done. And people were just trying to get their arms around what their data was and where it was and how to access it well. And that was important stepping stone, not only for what you're doing, but what the broader AI market needed in order to be able to train AI models as well, right?
Yeah, I think the big key here is that when you have that much data, oftentimes we would say that you have to have domain expertise to work with any type of modeling or ML because you just don't know where to look. So you work on that lived experience. And one of the things that we did that was very different is we said, well, what would happen if you made no assumptions, right? What would happen if you could go in and actually you could mine this data and you could surface out all the things that were actually important, not with any guesses, right? And then you could use your domain expertise to understand that, to interpret that. But how do you actually pull out of the haystack every single needle that's important? It's not just one, right? And the way we ended up doing that was we ended up basically coming up with a bit of a controversial take. We said, okay, what we're going to do is we're going to bring in all data, no matter what that data is. And then we're going to brute force compute every single connection, trillions of connections. And by doing that, we can then understand everything down to its core. And so you don't require a human to guess the taxonomy of the data or the type of the data, right? We can literally surface it out of that. And then we can do incredible things with it. But you could think of this as you wouldn't even know where to train otherwise.
Yeah. And it's fascinating as well, like the application that you guys are working on with all the amazing programming code that you've figured out the way to do that, like having to, then look at what the computing stack is and the software stack is that's going to be behind that. What you guys are investing in is essentially the same compute stack that, when you look at NVL72 from NVIDIA in the news, it's mostly frontier model builders and cloud platforms. And it's like you look at the list of people deploying this supercomputing scale technology. And then it's like, like this is actually, the stack that's required to solve hard problems, which, for NVIDIA, our entire goal is to solve the hardest problems in the world through the application of AI, data science, accelerated computing. We build these, libraries of software to help people accelerate raw mathematics, help people accelerate neural networks.
And we use a lot of those.
Well, this is where I'm getting to, right? The adoption of technology that you guys are looking at is stuff that we'd normally see in scientific computing.
Yeah.
And that's why it's really, really interesting, and that's what we look for when we're finding partners who are solving really hard problems.
I think it's really interesting. I wrote 87,000 lines of CUDA GPU code last year. Like a lot.
There's probably a award in that somewhere for you.
And there's a lot of lack of sleep in that.
Yeah.
But one of the most interesting things about is you have to think differently. Humans by nature, we often think of things as a sequence of singular tasks, right? I want to do this, then I'm going to do this. Think like you have a planner, right? You do this, this, and this, and that's going to work out. And actually that works really well in business. When you're working with NVIDIA hardware at this supercompute scale, it's like everything everywhere all at once, right? And so like you are, you have an asynchronous, we call it synchronous is like when you have to do one step after the other, right?
Yeah.
Asynchronous, multi-threaded. So it's like you can do multiple actions at once. And you just have to think differently about how your brain works and how you might solve a problem. And so for us, we're like, because when we first set out, we're like, okay, we want to build the causal connection between every single piece of data that exists, whether it's TV, down to radio, down to actually the sale, down to like delivery mechanisms, delay in sales process, whatever. Everybody's like, that's impossible. It's a exponential problem, right? You add a number, every time you add another thing, it's exponentially harder to get the computation. And we're like, well, what would have to be true if we wanted to do it anyways? Right? We didn't go, oh, that's impossible. That was everybody's response. Yeah. And NVIDIA, when we talked to them, you were the first ones who were like, well, yeah, maybe we should try.
Yeah, and that's, NVIDIA's approach to many things is like, the impossible should be possible. Like we've gone through the last 30 years of, placing long-term bets on things that people have said is impossible or incredibly hard.
I've always said NVIDIA is the company of the art of the possible, right?
Yeah, that's the goal always, right? When industries face incredibly hard problems, whether it's, in healthcare or autonomous vehicles, robotics, marketing, advertising, graphics, our goal has always been keep pushing forward, place long-term bets to solve those hard problems, right? Jensen was saying yesterday here that, in some interviews, we started working on ray tracing for games 30 years ago. It took us 25 years to make it real time.
Yeah.
Right?
Absolutely.
DLSS, which is a technology I know that you're very interested in, even though it's primarily built for graphics and rendering. But, we started working on that many years ago. It takes a long time to perfect. And now it's deployed across nearly every single game.
It took us 6.5, 7 years to figure out how to do this.
Exactly, right?
First, we had to
long-term bets and hard problems.
Yeah, so first we had to build a signal processor that could even see unstructured data. There's a lot of people who loved working with structured data. I'm like, you had to build something that could understand messy data. After we built the messy data, then we had to figure out how to connect everything at scale. So that was where we really, when we bought our very first supercompute cluster, the smaller one, that was where like we did it. And then after that, we were like, okay, now what happens if we want to predict the future of all those connections, right? And that's really what, or if we want to predict entire markets, right? That type of scale that basically we were looking at the past for a long time, doing attribution as we call it. Now we're looking at the future about how we do allocation. But that takes even more horsepower than the previous one because you're basically trying to predict. And so moving from, being able to do the signal process to being able to understand all the previous connections to now being able to predict the actions of all those connections.
Yeah. I mean, it sounds like an incredibly powerful source of information for the agents that people are building for advertising and marketing, right? Because this isn't that, right? This is a really important distinction in what you guys are doing, is that this isn't LLMs accessing a vector DB like a lot of intelligence models are today, which are amazing and have incredible uses. But I think you're creating that intelligence layer that agents can access. Is that something that you guys are?
Yeah, and I think the way we the way that we talk about this is like ChatGPT, Claude, all the amazing tools, right? And we use them ourselves.
Yeah, as do we.
But the problem you've got is that they don't understand multi-phase in the past. They're trained on a singular point in time, right? And that singular point in time, what we're looking at for us as a business, we're being like, okay, so what was it like here back in the past? What was it like now? What might it be like in the future? And then we want to be able to do it. So we actually have, if you think about, we hear about tokens a lot, right? Yeah. So if most of the models nowadays are images are your tokens, text are your tokens, right? Video is your token. Our token are the decisions themselves and actually the outcomes of those decisions, whether it worked. And so a good way to think about our model is the first set of training we do is on the data as it was, and then what our prediction was. And then we actually go back through every time step and we actually reinforcement train on whether that was actually the right decision.
Yeah.
And so, first we had to have the model to trade the data on. That was our previous, we brute force this world model. Then we train on top of that world model to do it. And that way you can feed what is the right action to something.
Yeah.
And so we always view ourselves as much more, we don't want to build agents. We want to be the agentic controller or the agentic understanding of things.
Yeah.
That layer that you want to lock into. And then that way, agent might be a human, an agent might be a machine, it might be a mechanic like a robot, it could be whatever, but you're still going to want centralized planning and understanding. And that's really where we squarely sit. And so we partner with a ton of agentic companies, just providing them access to that intelligence layer.
Yeah, I think that it's part of that flywheel that has been coming into vision and into reality. It feels like, there's been the blurred view of a truly, dynamic, always on, hyper personalized capability across marketing teams, agency teams, AdTech world. And that's starting to come out of blur into like the technology is not only available, but it's economically viable because of what's available, where it's available, how we're designing and pushing architectures forward.
We had to build a whole new architecture with you to do this.
Yeah. And
so now we have this, like we lovingly call it the Guru and Minion project that we do, where we have like these huge, and it's very much in what they do. We have these huge training machines, right? These monster, like you say, like the same thing the foundational labs use. And then we've just started deploying on the edge these real-time rendering machines that can then render or do the inference for this analysis that we're delivering everything directly off of GPU, but in real time.
Yeah.
And so that having that speed of access. And so we have the big, central compute system.
That access to real-time intelligence is one of these big shifts that's happening across not just this industry and media and marketing, but across many, many industries. It's like we've maybe have solved a hard problem, but it takes 6 months to get the results.
Yeah, and that's
how do we bring that down to real time?
And that's what we've been focused on for the last 6 months and this is the biggest comment from our clients. So, we could do I'd say 72 hours, we'd be pretty good, right? Classical modeling, often you'd be like, it'll be 2 weeks for the next run to come back. Then we got lowered that time frame to be down a few days. What we have now is we've actually just deployed to the first customer the ability to literally do the modeling and response in real time.
Yeah.
And so that will be literally, you could be we actually call it the shopping cart. You could be like, well, what if I wanted to do one more influencer, 2 more TV ads, and 3 more something else? You can throw it in a shopping cart and you can hit simulate, and it will instantaneously send the fleet of GPUs to go get the answer and bring it back to you in seconds.
Yeah.
And that is something that normally would be an analysis that would be days.
Yeah.
And so, we want to do exponential compaction, right? What does it look like to be 1,000x better at something?
Yeah. And that's, one of the reasons that I think, we have a strong developer working relationship is because you have those same goals that NVIDIA's engineers do. It's like, how do we, how do we make something 1,000 times faster? Not just 1 time faster, not just 20% more
incremental
efficient.
Is no fun.
No, exactly. Right. When we look at, what success looks like, it's, what's the X factor, not percentage factor. How do we increase this by so many times that it's going to change the industry, that it's going to change a market, that it's going to change
the first time we ran a model on this new stuff I was talking about, it took 36 hours before we ported everything. And that was when we were using pure Python. when we ported everything to pure raw CUDA C++, we can now do that exact same operation in 22 minutes.
That's why we've been spending the best part of 25 years perfecting CUDA and all these libraries, so that when someone has an amazing idea, we can very quickly help them improve and go faster and keep going. And the feedback that we get from you and your engineers obviously then helps us to keep improving at NVIDIA, right? So that's incredibly important part of
But I know, I mean, there is nothing more fun and exciting. One of the reasons I love working with NVIDIA in general, there's nothing more exciting than building the future. But making the future move fast is what's key. And I think that, I think a lot of companies go in and think like, oh yes, GPUs, whatever. But like, to make something exponentially faster is engineering merges with being an art form, right? You actually have to deeply understand what you're doing and everything. You can make it go 2 to 3 times faster pretty easy. Yeah, right?
I mean, we've always said, NVIDIA operates at the intersection of art and science.
Yeah, well, that's why we call it Alembic, by the way, is because alchemists, right? Alembics were a tool by alchemists, and it was a mixture of art and science, alchemy, right? So same type of vibe.
Excellent. Well, that seems like a perfect point to finish up the conversation today. Building the future is
always
the most exciting thing, and working at the intersection of art and science.
Yeah, and we'll work more soon.
Excellent. Thank you.
All right.